Time for an upgrade. Let's talk about advanced towing tank testing. Hello everybody, I am Nick the Naval Architect. The towing tank started with basic resistance and speed predictions, but as ship science advanced, our use of the towing tank also expanded. New gadgets and advanced capabilities, far beyond the single-purpose testing facility. Our modern-day towing tank has expanded into a Swiss Army knife of experiments, pushing the capabilities of naval architecture to whole new limits. Time to see what new tricks the old tank holds for us. Just for a quick recap, towing tanks are experimental facilities used to test models of ships. Basic idea, have a giant pool of water, put a model of a ship in there, tow that model by a towing carriage, measure the force on that model, and you can find out all sorts of fascinating information about the resulting ship. But that really doesn't do it justice. Instead, I want you to start by imagining a massive swimming pool. No, you're not thinking big enough. Scale that up to a giant basin of water, several hundred meters long. You're not thinking big enough. Think bigger. I said several hundred meters long. It's going to be deeper than a person is deep and wide as a car. Next, I want you to dump a lot of bromine into that water. A lot of bromine, so that there's no chance algae is going to grow in there. Now we add on the towing carriage, which is this large moving platform that stretches across the entire width of the basin of water. Think of this as a moving laboratory that runs on rails, and sitting right in the middle of the platform underneath of it is where you tow the model from. This holds all of the important and expensive equipment. The scientists also ride on this carriage. All the sensors to record the experiment feed from computers that are mounted on top of the carriage. And these are no ordinary computers or ordinary sensors. These are very high level, very expensive computers and very expensive data acquisition systems. All of this is demanding extreme accuracy and precision. Everything on that towing carriage and everything in a towing tank is focused on one specific goal: obtaining highly accurate measurements from that ship model as we tow it down the basin of water. Okay, recap is over. Let's get into the fun part: advanced towing tank testing. The towing tank started out with basic resistance and speed predictions, but as ship science advanced, our use of the towing tank also expanded. That humble towing tank now includes advanced tests for the discerning naval architect. These include seakeeping tests, maneuvering tests, and ice-breaking tests, to name a few. And if you want to go even one step further, you can even create your own customized testing. But today we're just going to talk about those 3 standardized tests. The first major advancement was to add waves to the towing tank. The most important part about wave generators is not their ability to just create any old pattern of waves. The important part about a wave generator is to create a specific combination of waves to reproduce the exact sea state that you're asking for that would match something in real life. When that pattern of waves combines with the model traveling down the tank, we are able to reproduce realistic seakeeping conditions. This allows us to test the ship response to bow waves. Well, what kinds of information can we get out of that? One of the important things is we can calculate the average increase in resistance due to those waves. That might be very important if you think about a ship in a storm. You want to know how much is it going to get slowed down in the storm? Or the flip side is, how much do I have to increase the engine power to ensure that it can maintain its speed during a storm? Another important consideration would be if you're a passenger on that cruise ship, you want to think about passenger comfort. So we're going to measure the accelerations of that ship and the magnitude of ship's heave and pitch. All of that features into passenger comfort. These measurements become very critical for preventing seasickness, which if you've ever been seasick before, you'll really thank us when we do these tests in the towing tank, because we can predict that and reduce it. Now the beauty behind this whole seakeeping test is generalization. Measurements for a single wave system, well, that doesn't do much good. I mean, what are the odds that you're going to encounter that exact combination of waves on the open ocean? Out of all the possible waves out there, not very good. But instead, designers use the towing tank measurements to create a generic profile for the ship's response to any wave system. Now that's interesting. Those measurements now work for anything from just a gentle ripple to monster waves, but they still represent a customized response for your specific ship. And that's the important part. We're not guessing. We have the details and the custom profile for that one ship. Unfortunately though, towing tanks only work for bow waves, or just slightly off the bow. That limitation comes from the dimensions of the towing tank. They're long and narrow. We would need to turn the model sideways to capture beam waves or quartering waves. Now, you can technically turn the model sideways in the carriage, but if you do turn it sideways, you start blocking the passage of the waves, and that alters the physics. The blockage effects are what we call them. It alters the way the waves behave going around the model, and it now starts to look like the model is not sitting in open sea, but it looks like it's sitting inside a gutter, which in fact it is because it's a basin of water. So we can't really do that. If we're sitting inside a narrow towing tank, for seakeeping all we can really do is bow waves. Fortunately, bow waves happen to be relevant to many ship operators. In large storms, your standard practice is that you point the ship's bow into the waves. And so that's why most towing tanks come equipped with wave generators. The next test that we added was maneuvering coefficients test. Imagine you designed a new submarine or a warship, and you needed to guarantee precise maneuvering capability. After all, you're going to be out there in fleet formation or fighting for your life. You need to ensure that you can turn on a dime. So to achieve that, you need the full maneuvering coefficients for the hull. These feed into answering the most important question of how big of a rudder do I need? Unfortunately, maneuvering coefficients are a massive subject all of their own, but we're going to give you the 5-minute version here. For example, imagine you require 50 ton-meters to turn your ship's and yaw at 5 degrees per second, and another 30 ton-meters to accelerate and yaw at 3 degrees per second. Okay, we're well along the way to figuring out how big of a rudder our ship needs, or how big of a rudder our submarine needs. So that's where maneuvering coefficients come in, is if you have that data, you have a very good idea of what to do for designing your ship's control surfaces for maneuvering. Well, that sounds lovely and well and good. Unfortunately, those numbers that I gave you, I just picked those at random. To establish real coefficients, we need a maneuvering study. To achieve the maneuvering study, we add a new gizmo to the towing tank, the planar motion mechanism, the PMM. The PMM sways the hull side to side in a snake-like motion as the carriage travels down the tank. While this happens, we record all of the forces that the model exerts on the PMM posts. In simple terms, the side-to-side motion is the input of our maneuvering motion. Actually, it's combining multiple maneuvers into one. And our sensors are recording the force required to achieve that motion. Then we add in some math to process the measurements that we're getting out, and we get our maneuvering coefficients. This is especially important for submarines. They also have to deal with maneuvering not just in the horizontal plane, but also in the vertical plane and rolling from side to side. So they have to deal with quite a bit complicated maneuvering coefficients. And so they do quite a bit more extensive maneuvering studies. Here's a fun one for you, an ice tank. I mean, even icebreakers need somewhere to go. And model scale icebreakers need model scale ice to test on. Specialized towing tanks are what this calls for. These specialized towing tanks include facilities to fabricate ice to a specific thickness and strength for testing. And the details change depending on the full-scale ice that you're trying to mimic in the tank. Now I have to admit, this is so specialized that it's fairly well out of my league. I don't know too many details about ice testing, other than really cool. The model testing does allow the designers to record the progress of their model as it goes breaking through the ice, so that you can record the speed of the ice and the power required. This can either be a self-propelled test or a test towed on the carriage. As you might expect, these facilities are quite expensive to use since you need to create new ice after you finish destroying the first sheet in your runs. I mean, think about this. Imagine if you were playing a hockey game. Imagine how long that would take if they needed to refreeze the ice rink after every play. Well, something similar happens in the ice tank. Clearly they try to maximize the use of the sheet of ice that they create, but still, you drag it down the tank, you break the ice. Well, sorry, ice is broken. Come back tomorrow after we've made a whole new sheet. If you happen to be somebody that's worked with an ice tank before, I'd love to hear more of your details. Add your information into the comments below. We're not done yet though. Sometimes even the towing tank will not be enough for the super advanced. We have to go even bigger. Ah, yes. Enter the maneuvering basin. This goes by many names. Maneuvering basin, ocean basin, some have the brand name flow wave tank. I'm going to go with maneuvering basin. The maneuvering basin gets around the blockage problem of narrow tanks by building a wide and gigantic pool. You're going to find maneuvering basins less commonly than you will find towing tanks, because these mammoth tanks come with a high price tag. And not just due to the size, but also from all of the gadgets that come with them. You have wave makers ready to produce multi-directional wave spectra, and what that means is you have at least 2 sets of wave makers on perpendicular walls that can produce crisscrossing waves. And that's very important because now you have 2-dimensional wave patterns producing very complicated waves, and when you have that, you can produce real-life sea conditions rather than just all waves running in one direction. Really neat. But we're not done yet. Now, on top of that, we add gigantic fans on top of the pool to simulate an ocean wind all the way up to the worst hurricane conditions. And we have massive underwater propellers to generate underwater currents, which can change direction. And we add an adjustable tank bottom to simulate different water depths. Usually this tank bottom can even go all the way up to the surface, which is really handy if you need to anchor a model to the tank bottom. People can just walk right on out and anchor it right there. Awesome. These maneuvering basins come tricked out with all the latest gizmos. And of course, a massive towing carriage and gantry across the entire thing, possibly even 2. Maneuvering basins see most of their work in the offshore industry, testing responses of moored offshore rigs or floating assets or other critical mission operations. Other applications would include general seakeeping studies, similar to what we did in the towing tank, but now we have the space to check all of the different wave headings. In recent years, even the offshore wind industry has employed the maneuvering basin to simulate the combination of marine waves and offshore wind for floating wind turbines. When you look at all of these different projects, the common element for all of these projects was larger available budgets and, most importantly, critical mission assets. You go to the maneuvering basin to answer complicated questions when failure is not an option. Maneuvering, ice testing, and seakeeping all expanded the towing tank until we needed even more. And for the truly ambitious, nothing will suffice but the all-encompassing maneuvering basin. Wow, there is a lot of fun stuff to play with in there. With all of these expanded testing facilities, designers gained the ability to customize and reimagine new tests to answer many of our modern questions in ship design. But it's important to understand that we didn't just build these things for the fun of it. Each of these advanced facilities grew to fill new needs from redefining the capabilities of the maritime technology. Advanced ship design means advanced testing. It's always filling a new need from pushing the capabilities of technology. So you really have to ask, what will we imagine next? Thanks very much. I am Nick the Naval Architect. Can you do a video on swaths? Yes, I can. Can you do a video on towing tanks? Yes, I can. Yes, I do custom requests. You can hire me as a professional engineer to meet the needs of your project. Check out my website to see the host of engineering services I provide, along with a range of other helpful articles and other useful tips. And be sure to subscribe for more videos.